Alright, so the following problem is is from page 278, and basically the problem scenario was Jack and Jill are maneuvering a boat which weighed 32 kilograms, and it gave us two positions of the boat, 2, 0, 3 and 6, 0, 1 meters. And during that distance, both Jack and Jill were both applying a force in order to maneuver the boat, and it wants us to find the work done by Jack, the work done by Jill, and the final speed of the boat. So work equals force times distance. So to find distance represents the displacement of the object. If the displacement is 0, then there's no work done. That's why the common analogy with when you try to lift a heavy object, even though you're putting a lot of effort into it, if the displacement of the object is 0, no work is being actually done. So you first find delta R of the boat, so which is final minus initial. Once you find that, you can find the work done by both people. So the work done by Jack was the force, which was negative, which was given to us, and the displacement of the boat. And this is the way you do the cross product. So in physics, when it's multiplied by things, when you multiply two vectors, you can't really multiply them. You have to take ax bx plus you basically take each component, multiply, and you add the next component. So since both y components are 0, you're only adding the x and z components. So as done right here. So the work done by Jack is negative 2,200 joules, and for Jill it was 0, which was strangely odd. So because Jill done 0 work, we can assume that it was, well, I thought it was 0 because maybe the direction that Jill was doing was perpendicular to the movement of the boat. So if it's a 90-degree angle, so work equals F times D, or work equals F times D times cosine of theta. So if theta is if the angle makes it 0, then no work is actually done. So when is cosine 0? At 90 degrees. Sorry, not 90 degrees. No, it isn't 90 degrees. Okay, so I think that's the other scenario of the problem. Lastly, what was the total work done? What was the final speed of the boat? So the final speed of the boat was just the change in kinetic energy. The total work equals the change in kinetic energy, which was the total work of both Jack and Jill, which was negative 2,200 joules plus Jill's 0 joules, which gave us negative 2,200 joules. It equals 1/2 mv squared. So we just solve for v, and we get 1.0886 meters per second. The units here do check out. You have mass times velocity squared, and on the left side you have joules, which once you divide by mass, you're going to have v, joules over mass, which would give you meters per second. So overall, I think this problem just wanted you to understand the concept of the dot product, and then how displacement plays a role in work. If zero displacement is done, then 0 work is done. That's why for point particle systems and extended systems, there's different work done by each thing on each object on the actual system. So I believe that's it. So thank you.